A particle P is moving along the line OX with an acceleration of 6t minus 18 meters per second squared at time t seconds. When t is equal to 0, the displacement of P from O is 0 and its speed is 24 meters per second in the direction OX, in other words, travelling to the right if we think about our number line. What other information do we have here? T is equal to 0, displacement of P from O is 0. So that's telling me x equals 0 when t equals 0. And the speed is 24 in the direction OX, means v is positive 24 when t equals 0. Find the values of t for which v is equal to 0 and the values of x for those two values of t. Okay, so we want velocity, which is the integral of acceleration. So that's going to be the integral of 6t minus 18 dt, and that gives me 3t squared minus 18t plus a constant. Now, we're given that v is 24 when t equals 0. Substitute v equals 24 and t equals 0 in here, and you'll find that c is equal to 24. And so v is 3t squared minus 18t plus 24. And we want to find when v is equal to 0. So that means that 3t squared minus 18t plus 24 is equal to 0. I probably should underline this because that's a result. And dividing through by 3 gives me t squared minus 6t plus 8 is equal to 0. And so that gives me t minus 4 and t minus 2 is equal to 0. So t is equal to 4 and 2. So we now want an expression for x, the displacement, and that's the integral of v dt. So that would be the integral of 3t squared minus 18t plus 24 dt. So that's 3t cubed over 3, so just t cubed. Take away 18t squared over 2, so take away 9t squared, plus 24t plus a constant. We know x equals 0 when t equals 0. Substituting in would give us c equals 0, and therefore x is going to be t cubed minus 9t squared plus 24t. And that is an expression for our displacement. Now we want x of 2 and x of 4. So it's just a case of substituting in. X of 2 is 2 cubed minus 9 times 2 squared plus 24 times 2. And x of 4 would be 4 cubed minus 9 times 4 squared plus 24 times 4. And we just need to calculate those. And you can see I've calculated and found at 2 seconds the displacement is 20 meters, and at 4 seconds it's 16 meters. So we want to find the distance traveled in the first 3 seconds. So one way that we can do this, if this is the line along which we're traveling, here's our point O, and we know that when we get to t equals 2, it has travelled 20 meters in this direction. And we know it's this direction because we know that the initial speed is positive, and we know that the speed is 0 when t equals 2. So that's the first time it stops, and therefore it must have been travelling to the right the whole time. Now, x of 4 actually doesn't matter to us because we're looking at the first 3 seconds. So what we really need to know here is x of 3. So just substituting 3 into our expression for the displacement. And doing that gives us 18 meters. And so it would be 18 meters from O, which means it's traveled back 2 meters. And in total, the distance covered is 22 meters. Now, can we do that with an integral as we discussed before? And you can see, looking at the calculator, that we can do exactly that using the modulus of the velocity.